All right, more examples. So let's start with 6. So here it says factor each polynomial, right? Here I have a difference of 2, right? It's a difference because I'm subtracting. There's 2 of them, and they're both perfect squares, right? 25 is a perfect square. Z squared is a perfect square, even exponent, and 1 is a perfect square. So I'm going to set up my two sets of parentheses. I'm going to take the square root of 25z squared, right? Mentally or on paper. And when I take the square root of 25z squared, I just get 5z. So I put that here and here. And remember, another thing you can do is just think of what multiplied by itself equals that number, right? So 5 multiplied by itself equals 25, and z multiplied by itself equals z squared. So I'm going to do the same thing with the 1. I'm going to take the square root of 1, or think about what multiplied by itself equals 1, and that would be 1, right? So I'm going to put a 1 here, put a plus and a minus, and we're ready to go. All right, number 8. So it's a difference of 2 perfect squares, right? So both variables, even exponents. 25 is a perfect square, 64 is a perfect square. So we're all set. So I'm going to set up 2 sets of parentheses. I'm going to think about what multiplied by itself equals 64u squared, and that would be 8u. So put that in the first position. What multiplied by itself would equal 25v squared, that would be 5v multiplied by itself, 5v. Then we put a plus and a minus. That's it. All right, let me show you some with some higher exponents, right? So here we have u to the 4th. So u to the 4th is a perfect square because it has an even exponent, okay? So this is a perfect square. This is a perfect square. And I'm subtracting them, right? So it's a difference of 2 squares. So I'm going to set up these parentheses. So u to the 4th, the square root of that is u squared, right? What multiplied by itself equals u to the 4th, and that would be u squared by u squared, right? So basically you just divide the exponent in half. Okay, so I'm going to put that here and here, right? This times this equals this, so that makes sense. Okay, then I'm going to take the square root of 81v to the 4th, which is 9v. Okay, so 9v squared, I should say. All right. Okay, then I'm going to have a plus and a minus. Now, here's where this one's a little different. So this is the factored version of this, but it's not completely factored. So look at these 2 binomials that we have left and think about which one can we still factor. And if you said this one, you're right. All right, now this is a difference of 2 squares. So I have 2 perfect squares, subtracting them, and so I can factor some more. Okay, so this one's just going to stay the same. U squared plus 9v squared. This is a sum of 2 squares, but we don't have, that can't be factored. It's not something that we have a pattern for. Okay, so I'm going to take the square root of u squared, which is u, so I'm going to put that here and here. The square root of 9v squared is 3v, so I'm going to put that here and here. Then a plus and a minus. And now we factored it completely. All right, number 11. So difference, right, of 2 squares. So this works. So we can open up our parentheses, take the square root of 16, which is 4, put that here and here. Take the square root of c to the 4th, which is c squared. And then a plus and a minus. Okay. Now, once again, this can be factored more. So I'm going to bring down the 4 plus c squared. So that's good the way it is. And then I'm going to factor this. So it's going to be the square root of 4 is 2. So I put 2 in the first spot. The square root of c squared is c. So I put that there. Plus and a minus. And that's completely factored. All right, and then the last one, number 12 here. So here, X to the 8th, that's a perfect square because 8 is even. The exponent's even. Same thing with the y. So I'm going to open up these parentheses. So I'm going to think about what multiplied by itself equals x to the 8th. And that would be x to the 4th, right? So I just divide this exponent by 2. And that's the same as taking the square root. Same thing with the y. It's going to be y to the 4th. A plus and a minus. Okay, but one of these can be factored more, right? That's a difference of 2 squares again. So I'm going to bring the x plus 4, or the, excuse me, x to the 4th plus y to the 4th. But now I'm going to open up parentheses for the second one here. So now the square root of x to the 4th is x squared. So I'm going to put that in the first spot. Square root of y to the 4th is y squared. And then we have a plus and a minus. Are we done? Not quite, right? So we now have another difference of squares. So I'm going to bring down these positive ones here, the ones that cannot be simplified or factored anymore. Okay, but this one here we can factor. So the square root of x squared is x. So I'm going to put that here and here. The square root of y squared is y. So I'm going to put that here and here. Oops, looks like an x. So then I have a plus and a minus. And finally, we're done with that one.